And it's time for another Incus release. This time around, we are looking at Incus 6.7, was released yesterday. And as usual, I'm gonna go through the release announcement, go through the main kind of highlights in there, and then attempt to do a demo of as many of the new features as possible. So, to get us started, the first one is actually related to the usual screenshots that we put in every announcement, and it's that it's significantly easier to access the Incus web interface. Prior to this, accessing the Incus web interface was pretty cumbersome. It involved enabling Incus to listen on the network, accessing Incus through a web browser, then dismissing the certificate warning because there was no good way to validate that, generating a client certificate from within the web browser, trusting part of that through the command line client, and then adding the other half of, adding the private side of the certificate into the web browser as a user certificate, reloading, and hopefully you get to actually interact with Incus. That was quite a few steps, quite annoying. These days, it's much easier. We've got a new command called Incus Web UI. You run it, and you get directly into the web UI inside of your web browser. The way this works is that the Incus command line tool itself runs a tiny web server over HTTP, so that avoids the HTTPS prompt. You connect through localhost onto that. The URL you get includes a token, like a one-time token thing to get trusted. And then you interact with that web server. Everything is then proxied using the Incus client's own authentication mechanism to the remote or local or remote Incus server. So it's a lot easier. It still should be just as safe. And that's going to be really quite useful for people who are not running production clusters that have a load balancer in front, valid certificates, central authentication, and all that kind of stuff. So if you just want to run the Incus UI on a laptop, on a small home lab or something like that, significantly easier now. Next up is for our clustered users. So over the years, the cluster mechanism has grown a number of somewhat expected but pretty useful features, things like live migration within the cluster, the ability to have pretty fine-grained scheduling and placement of new workloads, ability to automatically heal if a server goes down, and effectively with all of that easy ability to move things around within the cluster comes also now the ability to have the cluster rebalance itself. So it's a new set of config options that we have, which allows setting how often to go and look at the cluster load, trying to rebalance things, how many instances should be moved at most during one of those reviews, and how long after an instance has been moved should it be kept where it is. So that's the cooldown time, which is quite useful to avoid things just moving back and forth constantly. There's also then a threshold for like how much of a difference do we really expect between two servers to justify moving things around. By default, it's 20% difference in score, but you can set it to any value you want. And we effectively calculate an internal score on each of the servers based on the load average, number of CPUs, and amount of memory. And based on that, we can figure out just how actually loaded the different machines are, and like which one is the least loaded, which one is the most loaded, and what instances should be moved around to try and equalize things. Just to be clear, we don't actually use the load average just as its own data point there. Like when we talk about load, it's actually a combination score, because the load average on Linux just represents the number of tasks currently running or currently waiting to be running on the CPU. So an ideal load average is effectively equal to the number of CPU threads, despite what a lot of people have kind of gotten used to. It's not uncommon to see people expecting the load average to be like below 1 for things to not be busy. That's just wrong. Like if you're on a system with 384 CPU threads, your ideal load for like maximum usage of your resources would be 384. So that's why you need to actually consider the number of actual CPU threads to properly understand your load average. So we're doing that, we're calculating a score that makes sense, even if different machines have different number of CPUs within the cluster. All right, next feature we have is DHCP renewal for OCI containers. So application containers, they don't really handle their own network configuration. They expect things to be already there and be working for them, which is a bit of a problem for us because we usually configure things through DHCP. The way we've done it so far is we were doing a one-time DHCP request on container startup, picking up that info, configuring the network in the container, and then moving on. The problem with that is we were not doing renewal. Not really a big issue most of the time because our DHCP server is DNS mask. DNS mask always pings before giving the leads to someone else. And it also doesn't do sequential IP allocation. It does a hash based on the MAC address. So not really an issue even if we were not renewing when we're supposed to. Problem is that by not renewing, then any DNS record that's created by the DHCP server does go away. So that's a bigger problem. And so to fix that in Incus 6.7, we actually have the DHCP client stick around. So it effectively runs as it usually does, and then it backgrounds itself and attaches to the container itself so that it can handle lease renewal. Next up is for those who are actively using the refresh feature we have in Incus copy to create backups of instances. And just as a reminder of how that works, it effectively lets you copy one instance from one server to another and then repeatedly run refresh to update that remote copy. It copies any missing snapshot and then copies the actual instance state as well. The problem with it that can happen is if you don't want to store the same snapshot list on the source and target, for example, your target backup server only needs like one snapshot per week or something like that. You don't really want the next refresh to go and always resync the snapshots you might have deleted on that server. So that's what we've now sorted out with a new flag to the comment called refresh exclude older, which means it's just going to compare the snapshot list, find whichever is the newest snapshot they have in common, and then synchronize any snapshot from that point on. So if you delete some older snapshots and use that flag, then they won't come back, which is really useful for backup servers that are trying to save space and need to clear some of the snapshots while still having clients keep sending new stuff with the refresh flag. Next up is on Incus Top. So Incus Top is good at getting an overview of what's running on your Incus system. And until now, it had some keyboard shortcuts to try and change some of the output, but it didn't have our usual set of flags. So we've now changed that. It does support -- format, specifically both the compact and normal table output, and it supports configurable columns. So you can set those to tweak exactly what you want. And you can also pass the refresh flag to tell it how often to refresh. So that combined with our built-in command alias feature within the CLI makes it pretty easy to define like custom views of top effectively that already have all of the settings that you want applied. Next is on the oven side. So for oven networks, one feature that was missing was the ability to control your DHCP ranges. So what exact IP addresses, like IP address range you want to have used for DHCP leases. It would just use the entire subnet minus the first and last IP addresses. So now there's a way to configure that. You can set one or multiple DHCP ranges and it will pick IP addresses within that. Next up is still oven related. So it's about reconfiguring the physical network. So with oven, you always have an uplink network that's used to actually put virtual routers on, and that is often an external network, so like a VLAN or physical NIC or bridge or something like that, which you then tell Incus about, and it will just go and configure oven for that. The problem is if you've got some kind of reconfiguration at the hardware level, and you want or you need to move it to a different VLAN or something like that, there was no way to change that value. You effectively had to get rid of all of the oven networks, and then you could go and change it and then create the oven networks again. Really annoying because that breaks everything. Now we've got the ability to go and change that parent property at runtime, and it will go and reconfigure the affected oven networks to move to the new uplink. So that's very convenient. Not something that most people need to do, but if you need to do it and you're in production with hundreds of networks, you're going to be really happy to have this. Next is on virtual machines and the pretty low level side of virtual machines. So either in last release or the one before, we added a new mechanism to run a scriptlet as part of QEMU, so virtual machine startup. And what that does is it actually lets you upload something that looks like a Python script, which can then send commands to QEMU internally, get the response, analyze the response, and send more commands. It's pretty useful if you need to do stuff that Incus doesn't really want you to do, but that you still need to do it for some reason, like reconfigure some driver or some weird QEMU options. So far, everything was done through a single command called run QMP, which was effectively being fed raw JSON and would give you JSON back. Not exactly the easiest thing to work with, so we've added a few wrappers. The first one is a run command wrapper, which you can just pass a command name and some arguments and it just goes through. Pretty nice and easy. And then we've got more specialized wrappers that save you even passing the command name. And those are for things like block devices, character devices, generic QEMU devices, network devices, and QMP objects. So that's a bunch of functions that should make it quite a bit easier for those who are using that pretty advanced feature already. Next up, and somewhat related, we now have a new log file called qemu.qmp.log, which logs all, well, most actually, of the QMP exchanges. So what command we're sending, what reply we got. That makes debugging the scriptlet a lot easier. It also makes it easier to understand exactly what Incus is doing behind the scenes, because those QMP commands, they don't result in anything in the normal QEMU log or in the QEMU config file or anything anywhere visible. So by logging those now, it makes it quite a bit easier to see exactly what's going on. And still talking about scriptlet, but this time on the cluster and specifically the placement side of things, there is a new function that we're exporting now, which is called getInstancesCount. And that's used to, as the name implies, get an instance count. It can do some amount of filtering. So if you just call it as it is, you're gonna get the number of fully created instances across the entire cluster. You can filter that based on the location, so a specific server, or a project, or both of those. Additionally, there's a flag to set whether you want to also include in the count instances that are not fully created yet. So looking at instances that are currently in pending state, effectively, so that are currently being created. This is particularly useful to handle parallel placement requests, because you might have like a dozen different instances being created at the same time, and if they all run the same scriptlet, you might just end up overloading one server, because if you're not getting an accurate count of what's going on, you're just gonna keep shoving things to the least busy server, even though it's already creating a dozen other things. So with that, you can actually get a more reliable count, which is actually what Incus has been using internally for placement for a number of years now. And lastly, we've also added support for the format option to the Incus admin SQL command. That's particularly useful because if you select a single column and row, now you can do format CSV, and that gets you just the raw value. So if you need to script anything around the database, even though I would never recommend you do it, like nobody should normally interact with the database directly, you can actually use that as a convenience. And that's it for the overview. So let's go and then try and show all of those. Alright, so switching to a terminal here. The first thing is the Incus UI. So let's just get that one going. First, I'm gonna make sure I've got the web browser that's open, just so it doesn't show on a different screen or something. And then I'll just do Incus web UI. And it still went on the wrong screen. Okay. So let's try that again. Let's do Incus web UI. There we go. So when you run it, it gets you the URL to open. It also tries to open it in your default web browser. And as you can see, you just immediately get to see exactly what's running on Incus through the web UI. And you can do all of the normal interactions, get a terminal, live interaction with a console, everything works. It's connected over HTTP to a random port on the loopback device. And as we could see in the initial call here, it does include that token, which then results in a cookie for any other page to be loaded afterwards. So that worked really well. It's a lot easier. You don't need to have Incus on the network, and you can also run that against remote servers. So I could do, what can I do, like this one? So you can run a remote and the exact same works, but now I'm actually dealing with a remote cluster instead of my local machine. All right, so that's for the web UI. Next is the cluster rebalancing. So for that, we're gonna need a cluster. Switch to one. There we go. So here I've got a cluster. It's running a number of instances, as we can see. And let's look at the load. So load is actually pretty similar, except for the fourth one, which is quite a bit more loaded. Okay, so that's good. Now let's go look at our config. I already have some config keys in place for the rebalancing. So it's currently configured for a 1 hour cooldown and a threshold of 10%. Given the massive gap we have right now, we can probably tweak that a bit and we can reduce that threshold to 20%. Just make it less likely for things to keep moving back and forth. So that's the 20, that's the default anyways. And then we need to set the interval. By default, it's not set, so it's not running. And we're gonna just change that to an interval of 1. And then we're gonna go look at lifecycle events, which is what's, it's the cleaner audit log of Incus, which shows, in this case, gonna show the instances moving around. So we need to wait, in theory, up to a minute, potentially slightly more, because we will only get the notification once something has moved instead of when it's moving. So it can take 30 seconds or something for a given virtual machine to move around. That's probably the other thing worth mentioning with that feature. We can only rebalance things we can live migrate. So it's only going to be virtual machines, only those that are configured for live migration, and only those that don't use any kind of local resources. So we can see it just moved one, RH9-V1. So if we look, RH9V1 is now on 0.1. And it obviously used to be on 0.4. So this has now moved one instance. Let's see how much it affects the load. It's actually made it slightly worse. So this is actually a good point to raise. Don't actually run it every minute. That's a very bad idea. We base it partly on the load average. In this case, all the servers are identical. So the load average is the main thing that's being considered. And the process of live migrating consumes CPU. So it's gonna cause a spike as it moves, which means that you should really only look at running every 15 minutes to half an hour for rebalancing, so that the load scores can really stabilize. Because otherwise you're gonna keep moving things away from the same system, which is then gonna be empty and you're gonna have to move things back. So in this case, we can see the machine was still the most loaded, so it just moved another one away from it. Let's see if that's causing any difference. Yeah, not really. So at this point, it would still keep going and it's gonna mostly empty it, which is not exactly desirable in this case, but it does show what's going on since we asked it to run every minute. It's exactly what it's doing. All right, so I can keep this one going just for fun, but let's go look at some other feature now. So DHCP renewal for OCI containers. So for that, we need a OCI container. So let's just create an Nginx container. I think I already have the image. I do. That was quick. And now if we go in there, I would look at PS, but I'm pretty sure it's not installed. It is not. So let's install PS in there. Then we can look at the process list. And when we look at the process list, we can see this process here, Incus DHCP. So that's the process that's now lingering in all of those containers and handles DHCP renewal. So that's basically it. It's there, you're good. As you upgrade to Incus 6.7, you're gonna need to restart any instance that's already running to have it pick up that process. But if it's already running fine today, no real reason to restart anything. All right, next up is the ability to do partial instance or volume refreshes. For that, I need two systems. So I've got two VMs standing for that. Okay. And in here, I've got nothing on either of them, but I do have a remote, so I can easily copy stuff back and forth. I'm gonna go and do an Incus create of a container. And then we want to do a couple of snapshots. Okay. So if I look at this, now we have a container with 2 snapshots, and we still have nothing on the target. Now we can go and copy it with just normal refresh copy. And now source and target are identical. Here we can show the live snapshot list to just see what's going on. And let's add a couple more snapshots for fun. There we go. Do another refresh run, and they're good. Now, if I was to look at the normal behavior and delete some stuff, so if I go here on V2, instance A1, and we want to do snapshot delete, and let's say delete 0 and delete 1. Okay, I deleted these 2. And then I'm gonna go and create another snapshot on the source. And then I do a refresh. Now it's repopulated 0, 1, so they got recreated and transferred 4. Not exactly what we want, but now if we want, well, that might have been what we wanted, but if we didn't want it to restore those deleted snapshots and just copy the new stuff, that's where the new flag comes in. So if we do a refresh and we do refresh, refresh exclude older, then now it's gonna notice that the latest common snapshot between the source and target is snap 4 and only transferred snap 5. So if we go and look at our source, the source still has 0 through 5, target has 3 through 5 now. So that's the new feature. It's going to be really useful to a bunch of people using snapshots and copy refresh for backup purposes. Next up is Incus stop. So if we look at Incus stop, by default, that's what it looks like. And you can do some amount of changes, like changing the delay and that kind of stuff through the interactive prompt in the command itself. But now you can also do that directly through the CLI. So you can change the default refresh that way. And you can also go and change the columns that are being showed. So if you do C and say we want instance name, CPU usage, memory. There we go, instance name, CPU, and memory. And if we want to change the output to, we can't do CSV or JSON, but if we want to do the compact table, we can do compact now. And if we wanted to even hide the header, we can use even the qualifiers and do no header. So that's it for the Incus top command changes. Works pretty much as expected. And now we're gonna go back to our cluster. So, and it even wants to move the big one. So I guess that means that server 03 became the most loaded and it went and moved the big Windows VM. Okay, interesting. Let's look at our load currently. Okay, so it did reshuffle things. They're effectively pretty well balanced except for 03, that's pretty full now. So it's gonna go and pick something out of 03 to move around. Which I guess it did, it moved the Windows VM, but it's not caused the load to drop yet. So it's probably gonna go and pick something else to still move it around. Anyways, we're not here for that, we're here for oven. So on the oven side, if we go look at what we have here, we've got 2 networks. We've got our default network, and we've got a other test network called bar. If I go look at the config for bar, we see it actually already has a DHCP range configured. So let's remove that for a minute. And then let's do, okay, it's too far away in the history, never mind. Let's do a new instance. So let's launch Alpine Edge, call it A1, put it on network bar and on local storage. Okay. And then we can see it pick the first address in the range, so 10.179.82.2. Okay, let's delete that now and edit the network again and go and put the range configuration. So from 100 to 200 within that subnet now. Launch again. And as expected, we're getting .100. So that's basically it for this feature. Works as expected. It's just a bit difficult to make it work on oven because it works kind of in the reverse. It doesn't really take DHCP ranges so much as it takes reserved ranges, so we had to just reverse the logic. But we managed to make it work, and it lines up now with what we get on DNS mask. Next up is going to be the QEMU scriptlet. So I've actually kind of prepared for that already here. If we go look at my default profile, we can see it's got something in there. So I did put a scriptlet in my default profile for all VMs. And we can see it defines the QEMU hook, and what it does is it logs an error. That's convenient because that lets me easily see all the errors here. So if I do on the error level, that's going to keep it pretty nice and tidy as we do things. Okay, so in here, what it does is whenever the hook is called, it logs just a prefix to know it's my stuff. Then it shows us the stage that's being passed, and then it does a actual command using query status. So that's one of the new features, effectively, that's run command wrapper to make things quite nice and tidy. So if we go and launch, let's do Ubuntu 24.4 as a VM, let's call it full VM and put it on local storage. Okay, we can see it's calling the instance placement scriptlet. We can ignore that for now because that's going to be, I think, the next feature or something. And then we've got QEMU scriptlet, and it shows being called 3 times, early, pre-start, post-start, and each time logging us the status. So the first time was not running, pre-launch, second one was still not running, still pre-launch, and the last one was we're running and status is running. So that's effectively how you use the scriptlets, and in this case use the run command function. And now if you want to look at what that looked like, let's see what machine it's on. Oh, conveniently it's on the right machine. That's cool. Okay, so I can go look at the logs now. So if I log Incus, and we want v1 and QEMU understand v1's through, and then QEMU QMP log. So now we have this thing, which logs everything. So we can see a few calls to query status. So that's probably our pre-start scriptlet that did this. Then there's going to be another call, so that's probably our post config or something like that scriptlet. Then the actual initialization is done, and then we're calling it yet again, and that would be the post start. So, and then because we did a list which also calls query status, we can see some more calls happening. So that's effectively that. You now have a detailed log of everything that's going on the QMP side, and makes it pretty easy to see exactly what Incus is doing. Like up here, we can see the dump of the CPUs configured in the VM. Then we can see Incus configuring the network interface, so injecting the network device and injecting the PCI device for that, and then doing the same thing for the disk. So the more complex the VM, the more log entries you're gonna get, but you get to actually see what's going on behind the scenes now. Next up is the placement scriptlet. So you may or may not have seen it when I did it earlier, but we can just keep doing it. So if I do the container, so let's do Alpine there, okay, and clear that log. So if I just create A1, we can see an instance placement scriptlet call being done. So we see again my prefix, it's a new instance, what project it's in, etc. And the most important thing here is actually the last one, which is the count. Now if we go look at the scriptlet itself, actually let me just get the config key and show you that, it's gonna be easier. Config get this. So again, the scriptlet is pretty minimal, it doesn't do anything useful, but what it does is that get instances count, which doesn't count just the current instances, but the actual pending ones. So I would expect that if we just get a count, okay, we're currently at 12. So if we were not including the pending ones, when I launch another one, it should say 12, but you'll see it says 13 because it already knows that there's a pending one. You also notice that the candidates list changed order. That's because it is sorted based on the number of instance plus pending instance per machine by default. So if you just pick the first one out of the list, you're always going to pick the one with the fewest instances. And this can obviously be tweaked a fair bit. So I could do, actually let me do edit here, and we can go here and actually say I only want to see the count, on, what would that be? Candidate members, first entry, and now on the name of it. Okay, so now in the log, it will just show me the count on the server it's headed to, including pending entries. So we can see 3 now. And if we do another one, it's gonna probably end up somewhere else with a different count. So 3 again, but different server. So that's that feature. It effectively makes it quite a bit easier to really properly analyze what's going on and where you should go. And that's particularly useful if you're dealing with like big parallel batches of instances getting created, because by using that, you can now get a better idea of what's pending and avoid all of the requests going onto the same server and overloading it. Alrighty, and the last thing on the list is just a small improvement to the SQL command. So if we do, say we do this, that lists all of the database, all of the servers in the cluster. Now, if I was to do name, then we get a single column, which is convenient. And once you get that, if we do, now I want format, we could do compact to get something a bit easier to read. And that obviously works even with all the columns. You can also do the things like JSON and YAML if you need to parse them. It's a bit raw, but it works. But where it gets interesting is you can do CSV. And if you do in single column in CSV format, then now you get just a list of server, which happens to be very easy to parse and iterate over. So that's really quite convenient if you ever need to script this command. But if you need to script this command, you should probably come talk to us, because you shouldn't be scripting this command, basically. It's very useful for our tests, but for anyone else, you should really not be relying on that. And if you are, it probably means there's a missing API or something that we should try and do a better job at. And that's it for Incus 6.7. So as usual, it's gonna take a while to show up in distros. It should already be on our demo website. If you're using my repository for packages, it's already installed there. You can get it easily enough. And hopefully another great release with a lot of bug fixes, performance improvements, and some pretty exciting new feature that hopefully I did a good job at demoing for you. If you've got any questions, feel free to leave them down below in the comment section, or you can go on our forum, and I'll see you in the next one. Bye.